Hello guys, welcome to Self Help Maths Academy. Now today I'm going to continue with the limit discussion. So we will discuss today how do we evaluate the limits of our rational functions. That is our discussion. Okay. So evaluating limits of a rational function. Limits of a rational function. That is the discussion. So what is a rational function is first. So a rational function is a function of the type f of x divided by g of x, where both f of x and g of x are the polynomials. Okay, so rational function, if any function of this kind we have, then we call them as rational functions and rational polynomial, in fact. So let's see where f of x and g of x are the polynomials. So whenever we are evaluating the limit of this type of functions, so we are going to have, there are three cases mainly. So let's see what is the number one case. So the first case is, what if the limit, for example, if I want to find out limit of f of x over g of x as x tends to a. So if this limit we want to find, we're going to encounter three cases. When, if, first case is if g of a is not equal to 0. Means after substituting the value of x as a, if the denominator is not equal to 0, then limit of f of x over g of x as x is tending to a is simply f of a over g of a. So whenever you have the denominator not equal to 0, simply substitute the value of x equal to a in the numerator as well as the denominator. It's very simple one. And then if in the case 2, if it is actually g of a is 0, after substituting the point as x equal to a, if g of a, the denominator is 0, but the numerator is not equal to 0. If numerator is not equal to 0, then we have a vertical asymptote at x equal to a. Then we have to first examine to determine the limit. Then only possible value of the limit will be either it is plus infinity or the negative infinity. So when the denominator is equal to 0 and the numerator is not equal to 0, so then these are the two possible limits what we have. And in the case 3, case 3 talks about if both are 0, if the numerator as well as the denominator, if both are 0, then the direct substitution of this will give us, if they are 0, then it will be of type 0 by 0, which is indeterminate form, one of the indeterminate form. Okay, we call this as indeterminate form. Indeterminate form. Okay, so if that is the case, then you have to find the common factor between the f of x and g of x, and then we have to simplify it first. So that's how we have to take the common factor. Okay, then and there is a common factor which you have to consider, which you have to take out, and then you have to simplify both f of x and g of x, and then you have to apply the limit. So that's how we have to see. So there are the three cases which we are going to discuss now, and we'll see the examples one by one. Let's see. The first example is, say limit of x square plus 2 divided by x square minus 2 as x is tending to 2. Now, if you see, there are three cases out of this. It comes under which case? Let's see. First, this is in the form of f of x divided by g of x, where you can see this is your f of x, and here this is your g of x. And when I substitute the value of x as 2, what is happening to the denominator? When I substitute x as 2, it is 2 square minus 2, which is equal to 4 minus 2, which is 2, which is not equal to 0. That means your denominator is not equal to 0. So the denominator is not equal to 0 means simply the first case, you substitute wherever x is there as a and simplify it. That means I'm going to consider the problem where, since the denominator is not equal to 0, so clearly your g of 2 is not equal to 0. Hence, you substitute wherever x is there 2, it is simply 2 square plus 2 divided by 2 square minus 2, which is equal to 4 plus 2 divided by 4 minus 2. It is 6 over 2, that is equal to 3. So hence the value of this limit is equal to 3. So one example. Let's see another example now. If I have limit of say 1 minus 2x minus x square over 1 plus 2x minus x square as x is tending to negative 1. Okay, so first again this is your f of x and this is your g of x. This is your f of x here. You have got g of x. Again, this is a rational function. So let's see, the limit value is x is tending to negative 1. So let's substitute in the denominator. It is 1 plus 2 into negative 1 minus 1 the whole square. This is simply 1 minus 2 minus 1 the whole square is 1, and this negative 1 will be minus 1. So minus 1 plus 1 cancels. It is minus 2, which is again not equal to 0. So when it is not equal to 0, again the case 1, guys. So let's see. The case 1 says just substitute the value of x as 1. So this gives 1 minus 2 minus 1 minus 1 the whole square divided by 1 plus 2 of minus 1 the whole square. So this gives us equal to 1. This is minus into minus plus 2 minus 1 the whole square we have, which is 1, and this negative 1 divided by, this is you have already, so 1 minus 2, 1, this is minus 1. So minus 1 plus 1 cancels in both the case, and this is 2 divided by negative 2, which is minus 1. So these two examples which we have seen is from the case 1, where we have seen that the denominator was 0, and then we just simply substituting the value of the limit in both numerator as well as denominator. Hence, we'll find the value of the function. Okay, so now let's see another example where we will see how exactly we're going to calculate this. So the third example is limit x minus 1 divided by x square minus 1 as x is tending to 1. Okay, all right. So this is example. Now for this example, how do we approach to the problem? So again, what we do is I'm going to substitute. This is your f of x and this is your g of x. So let's substitute the value of the limit here in the denominator first. So this will be 1 square minus 1, which is 1 minus 1, which is equal to 0. Oh my God, we have got 0 now. So when we got 0, that means it falls under the case. And also you have to check the numerator as well. When it is 1 minus 1, it is again 0. So it is simply a 0 by 0 form, which is the indeterminate form. And when it is an indeterminate form, the case 3 says that we need to find out some common factors among the denominator and the numerator. Yes, well said. So now this implies, let's see what we can do here. This is limit as x is tending to 1. This x minus 1 we are keeping as it is. So this is, you can see this is pretty this way, a square minus b square. This is your a square and this is 1, we can write as 1 square, therefore it is a square minus b square. And when it is this identity, we know it is a plus b into a minus b. The same format, I'll write this as a square. So a minus b, x minus 1 into x plus 1. Okay, so now you can see here x minus 1 and x minus 1 in the denominator we can cancel. So we are just left with the numerator, in the denominator, limit as x is tending to 1 divided by x plus 1. Now simply wherever x is there, substitute the value as your denominator is not equal to 0. So since it is 1 divided by 1 plus 1, which is equal to 1 over 2. So this is the value of the limit. Okay, so let's see another example now. Let's see another example where we will be seeing this one. Say limit x square plus x minus 2 over x square plus 5x plus 6, and as x is tending to negative 2. So in this particular example, if you see the numerator as well as the denominator, we have to substitute the value and we will check what we will get first. Let's see. How do we identify this one? Again, in this case, this is your f of x and this is your g of x. Okay. So if I substitute x is equal to negative 2 in the denominator first, so this will be negative 2 the whole square plus 5 into negative 2 plus 6. This is 4 minus 10 plus 6, which is 0. How about the denominator, numerator? So numerator is negative 2 the whole square plus negative 2 minus 2. This is 4 minus of 4. So this is again 0. That means you have got here 0 by 0 form again. So when you got this, you need to find out the common factor of the numerator as well as the denominator as it has been told. Let's see, how do we do this example? Now this is limit as x is tending to minus 2. So here you can see this numerator, I can write it as x square because I have to have a factor where after multiplying I should get negative 2 and after addition or subtraction I should get plus 1. That means it is plus 2 and negative 1 because when I multiply these two I'll get negative 2 and when I add these two I'll get a plus 1. So therefore x square plus 2x minus x minus 2 I can write. Similarly, you can see in the denominator, I want after multiplication, I should get 6 and after addition or subtraction, I should get 5. So 3 and 2 are the two factors. After multiplying, I'm getting 6 and after adding, I'm getting it as 5. So let's take it as x square plus 3x plus 2x and plus 6. Now simplify this. So limit as x is tending to negative 2 and then here you can see x is out, so it is x plus 2, minus 1 is out, it is x plus 2, divided by, if I take x out, here x plus 3, and if I take 2 out, it is x plus 3. So further we can write this as, this implies limit as x is tending to negative 2, here this is x plus 2, x minus 1 divided by x plus 2 into x plus 3. So you can find the common factor of the numerator as well as denominator as x plus 2. I can cancel this. So you're simply left with x minus 1 divided by x plus 3. And after substituting the value of negative 2 in the denominator, it is still not 0. So hence just substitute the value of negative 2 in x. So it is 9 minus 2 minus 1 divided by minus 2 plus 3. The answer is minus 3 by 1, which is equal to minus 3. So this is the limit value for this particular problem. So now let's see another example of this kind. We'll see another example. We will have, say, limit e to the power x divided by 1 minus e to the power x as x is tending to, say, 0. This is the problem. Now again, this is a rational function. As you observe carefully, what we can do here is let's see, if I substitute, this is your f of x and this is your g of x. Okay. Now when I substitute in the denominator 1 minus e to the power 0, it is anything to the power 0 is 1. So 1 minus 1, which is equal to 0. That means you've got your denominator as 0. Your denominator is 0 and your numerator is not equal to 0. So you can see the second case. So in the second case, as per the rule, either it will go to the positive infinity or the negative infinity as per the sign here. So therefore, let's substitute the value of the infinity, the x value here. This will be simply e to the power 0 divided by 1 minus 1, which is equal to 1 over 0, which is infinity. So that is undefined. Okay. So this is the value of this limit. So we're seeing almost all the cases where case 1 and case 2 and case 3 we have discussed so far. And then we are finding out the values of this particular problem. Okay. So now let's see another example where we will be again seeing how do we get the limit of a function when we substitute the value. Okay. Let's see. So here we're going to discuss one more important and interesting under this rational function only, where we're going to use a different method to evaluate the rational function. Okay, whenever it actually terms involve the square root. So for example, if we have this, say, we want to find out limit as x is tending to 0, where it is 2 minus square root of x plus 4 divided by x. Okay, if this type of functions are there where the square root is involved, then we are going to multiply both numerator and denominator by a term similar to the numerator but with an opposite sign. So that's the idea. For example, if it involves this square root, then you're going to multiply and divide with the numerator, but it has to be opposite sign. If it is negative sign, you're going to use the positive sign. If it is positive sign, you're going to use the negative sign, and so on. Let's see, how do we calculate this? Now, limit as x is tending to 0. I'm going to write here this as 2 minus square root of x plus 4 divided by x. Now multiply and divide with 2 plus square root of x plus 4 divided by 2 plus square root of x plus 4. Okay, so this is how we're going to calculate. Now this is equal to, now you can see this is in the form of, if you observe carefully, this is like a minus b and this is like a plus b. So we know a plus b into a minus b is simply a square minus b square. Okay, so that I'm going to use now, that identity. So let's see, how do we do it? Limit as x is tending to 0, a square, that is 2 minus square root of x plus 4, a square, I'm sorry, we have to write it as a square minus b square, not a minus b the whole square. Okay, so a square minus b square we are using. So this is a square minus b square divided by, the denominator is simply x into 2 plus square root of x plus 4. Okay, so now this is equal to, simplify, limit as x is tending to 0. Okay, so here what we get, this is your 4 minus, this is a square, the square and square root will cancel here. It is simply x plus 4 divided by x into 2 plus square root of x plus 4. Okay, so here you can see this when you just take the bracket out, it is limit as x is tending to 0, 4 minus x minus 4 divided by x into 2 plus square root of x plus 4. Okay, so negative 4, positive 4 will cancel. You are having here which is equal to minus x upon x into root 2 plus square root of x plus 4. So this x and x also we can cancel. This is limit as x tends to 0. So when you cancel this, you're left here with is equal to negative 1 upon limit as x is tending to 0. So it is simply 2 plus square root of x plus 4. At this position, if you substitute the value of the denominator wherever x is 0, then it is not going to be 0. So hence I can just substitute the value minus 1 upon 2 plus square root of 0 plus 4, which is equal to minus 1 upon 2 plus 0 plus 4 will be 4 and square root of 4 will be 2. It is simply minus 1 upon 4. So this is the value. So please remember, whenever you have a square root involved in the rational function, then we are going to solve it by using this particular method. Okay. So alternatively, you can use the binomial theorem to expand. Just try it out for yourself and then let me know how do we solve it by using that method. And this particular expression and this particular method can be used only for the square roots. If it involves the cube roots, then we can't use the this method of solving. But if you are having the cube root and fourth root and the multiple roots, then we have to use the binomial method in order to solve the problem. Okay, so I think with this we are concluding the rational function and solving the limits. So in the next video, we're going to come up with the next method. So till then, take care, guys. See you all.